Guys, and welcome to this tutorial. In this tutorial we're going to be talking about how to calculate solar systems for homes. Now, in calculating solar systems for homes, basically what you calculate is your inverter rating, your battery rating, and of course you want to know your solar panel wattage rating. So all of that actually is important. So step number one, you want to calculate your home electrical load calculation. Like I've said it before, you calculate every appliance that you might want to connect to that system. Like you need to calculate everything. Then that way you get to determine what your inverter selection is going to be and what your battery selection is going to be, and the panel, of course. Step number one, home electric load analysis. Like you go through basically what you might need to connect to the solar system. Say for example, here I'm saying you have a 4 LED light, yeah, you have two fans you want to power on, and then one tube light you might likely want to power on, and a TV, one LED TV. So in all, haven't taken all of that. You take the total amount of load that is here in this case is 350 watt. So step number two, you want to determine your inverter selection, like your inverter rating in this case. Now the inverter rating, it usually has to be more than the rating of the load. So a range for this case, a load of 500, you might be looking at a range of 800 to about 1000 watt is best for that. So since we know the AC load is 350 watt and we're considering a battery, a DC battery of 12 volts, you could actually consider a battery of 24 volt depending on your demand. But in this case, we're using like 12 volt because they're basically lighting in just one socket outlet. So you calculate the current, and if you calculate the current using that formula, the relationship between power, you have 30 ampere. Now we look at the battery selection. Of course, the battery selection, you have the formula for the battery selection, which is actually equals to W times H divided by V, where W is the total load, and then we have W is the total load, and H is the backup time, like the number of hours the system will remain on is for about 8 hours. So having done that calculation, you will be having a total of actually 233 ampere, and 233 ampere is something you might not likely find on the market. So perhaps a round off to 250 or bringing it down to 200 would actually do for your battery. So the battery charging current now is usually 10% of your ampere current rating of the battery. So that way you know that the battery is actually charging at this particular uh, current. So having divided that by or multiply that by 30% to say, you would have 25 ampere. And 25 ampere, that in that way you could pretty much determine your charge controller and even your protective circuits. So for the solar panel current, it's usually equals to the battery charging current plus the home current, that is the home load current, like the currents are coming from the load, which we calculated initially to be 30. So in this case, you see that having add up that of the charging control or the charging current and the home current, a total of 55 ampere. That way we could actually determine the power of the solar panel using the relationship power with current and voltage, and that's going to give us, since we know the voltage of the battery is 12 and that current is 55 ampere, that gives us 660 watt as power for the solar panel. But we might not necessarily find such panel with that much capacity of about 660 watt. So there's going to be need for us to actually break it down into smaller panels. Say for example a combination of 2, 3, or even perhaps sometimes four. In order to do that, now we take that of 660-watt panel, we then divide it by some um you might divide it by three or divide it by four or say divide it by five, but but we know that usually the most common types of panels you find in the market are usually 125 watts, 180 watts, 375, and 440 watts. These panels are actually very much available in the market, so you might pick from a range of this. Say for example, the total number of solar panel is going to be total number of solar panel watt divided by a single panel watt. So this is just a rough way of actually achieving it. But in other words, you could actually divide the 660 watt by say 4 and the rest, and you get a value, and you that way you know how much you need. But this is one easy way to do it. Just divide the total wattage of the solar panel divide by anyone you know is usually found in the market. In this case, we're using 180, and you can see we have an average of 3 point something. So running off to 4, that means we need about 4 panels of 180 watts rating. So that's basically how you make your selections for solar panels. You see, we've looked at in the case where we have an inverter ranging from 800 to 1000 watt, and we looked at how we could actually get the battery rating, and we have 250 ampere. In that of the solar panels, we have 4 times 180 watts. So we need 4 different panels of rating 180. Now, with that, we'll be able to power up our system. Thank you. Yeah, guys, this video is just to give you an insight of how to go about the calculation. But if you want a more detailed information about inverter selection and battery selection, please do refer back to one of my videos I made earlier where I explained in details how you could actually select your inverter and your battery for your solar system.